Hi guys, welcome back to Symbolic Logic Part 24. So far, in Symbolic Logic, we have seen about compound statements, types of compound statements. After that, we have studied about truth table and we also used some problems uh, to prove the validity of an argument using truth table. And we have also seen about specific forms like tautologies in truth table, which we call it as specific forms. And we also used a truth table and specific forms to solve the problems. After that, we have studied about some rules of inference and replacement rules, and we have done many more problems using this toolbox, that is rules of inference and replacement rules, to prove the validity of a given argument. So, if you see, we have already learned in our previous 7 discussions how to prove the validity of an argument. So, to prove validity of an argument, we can prove through Venn diagram technique or through table chart method, and we have finally gone through formal proof of validity, which is meant by using the toolbox we built using rules of inference and rules of replacement. But what about an invalid argument? We are proving a validity of a valid argument. But when it comes to invalid argument, how we gonna prove? That's what we gonna see in today's session. Okay, so validity of an invalid argument. For an invalid argument, there is, of course, no formal proof of validity. However, if we fail to discover a formal proof of validity for the given argument, this failure does not prove that the argument is invalid and that no such proof can be constructed. It may mean only that we have not tried hard enough. Our inability to find the proof of validity may be caused by the fact that the argument is not valid, but it may be caused instead by our own lack of ingenuity. So, how can we prove an argument is invalid? Using short truth table method. An argument is proved invalid by displaying that at least one row of its truth table in which all its premises are true but its conclusion is false. I have already told about this method while studying about the truth table. I hope you have remember. So what we gonna do is let's see an examples and problems using this method so we can understand this easily. So, example number one, if the governor favors public housing, then she is in favor of restricting the scope of private enterprise. If the governor were a socialist, then she would be in favor of restricting the scope of private enterprise. Therefore, if the governor favors public housing, then she is a socialist. So, this is a question. As usual, when we in previous session we have used this thing to form an argument. So we're gonna highlight the connective phrases like if then, so we can know which is conjunctive or distinction, conjunction or disjunction. So if the governor favors public housing, so we have a b c three variables and we are assigning into an statement. If the governor favors public housing means we're gonna give a variable. She is in favor of restricting the scope of private enterprise means we're gonna give b. And if the governor were a socialist, we're gonna give c. So after studying this the whole sentence using the statement, we have built a implication b, c implication b, therefore a implication c. So this is the valid or argument we have built. So how are we gonna prove it? As you know, the valid arguments we will be proving using the technique of Venn diagrams or truth tables, are using these rules of inference and rules of replacement. But when it comes to invalid argument, we can't do anything regarding the validity. So one method which we're gonna use is shorter truth table method. How we gonna do is we have two premises and one conclusion, and we have three variables. So we will be having three columns and we will be assigning the values to it. What you need to do is the conclusion must be false and the premises must be true. If that's it, that's what you're gonna prove. If that is proved, then we can prove the invalidity of this argument. So what we're gonna do is let's assign A, B as T, T. So A implication B, what will come? If implication means T of T implication F, we will get false. Other than that, every value will be true. Okay. So we got A implication B, T T. So true. Okay. So this premises is true. So next we have C implication B. So let's give a value to C. Let's give a false value. So what will happen if you give true value? If C is true and B is true, what you will get? You will be getting 2. True only. So we can also give true. But what will happen if you give C true and A also true? A implication C, true, true. True will come, but we don't need true in the conclusion. We need false in the conclusion. So we are not giving true value to the C. So we are assigning false value to the C. Moreover, C implication B, that is FT will be T only. Only TF will be F. So no problem. So we have proved. So we have given true value for A, true value for B, and F value for C. After that, when we calculate, we got two premises true and the conclusion is false. So this argument is as proved to be invalid. Let's see the example number 2. So they have already given an argument with three premises and one conclusion: A implication B, C implication D, A disjunction D, therefore B disjunction C. As usual, we will be having four variables and we will be assigning the value to the variables and solving the premises. So when you do that, we have given F value to A, F value to B, F value to C, and T value to D. After A implication B, false, false, true we got. C implication D, F, T, true we got. A disjunction D, F, T we got T. So all the premises we got T. And the conclusion, B disjunction C, F, F, we got F disjunction F, we got F. So let's move to the next example. As usual, we have A implication B, C implication D, B disjunction C. Therefore, A disjunction D, same as the previous one, we will be solving the values to A, B, C, D variables, whether it is true or false as you wish. You can do it and calculate and again redo it till you get the three premises true and conclusion as false. As you see, in this example, we have negation. I disjunction negation J. As usual for negation, if you redo these things and solve these problems again and again, you will be expert in it. So that's all about the proving the invalidity of an argument. We will be using shorter truth table to prove an invalidity of an argument. So, in the next session, what we will be seeing is we will be seeing about a rule of indirect proof, rule of conditional proof, and rule of quantification.